Classification of compounds. Ionic compounds. Now, the word ionic is referring to ions. It's a compound, and if you remember, a compound is made up of two or more different elements. However, in ionic compounds, you have ions. You have cations, which have a positive charge. It could be +1, +2, +3. And you have anions. And anions have a negative charge. And positive is attracted to negative and vice versa. And that forms what we call an ionic compound. And so metals, given that they love to lose electrons to become positively charged cations, okay, and nonmetals, given that they love to accept electrons to become negatively charged anions, these positive and negative charges attract each other, and that's going to form your compound. So ionic compounds are formed between metals and nonmetals. The metals give up the electrons, the nonmetals accept electrons, and that's how you form the compound. So if I take any metal over here and I put it together with any nonmetal over here, the metal will give up the electron, the nonmetal will accept the electron. So let's try a couple of those. So if I have sodium metal and I have chlorine, the sodium is going to give up an electron to chlorine. That's going to give you Na plus and Cl minus, and that's going to form your ionic compound. So ionic compounds are made up of metals and nonmetals. Let's take a look at molecular compounds. Molecular compounds are made up only of nonmetals. On the periodic table that we were looking at just a little while ago, these were only the blue elements on this particular periodic table. So if I take a look at all these guys right here, and remember that noble gases really don't want to react. We can get some of them to react if we force them, but in nature they really don't want to react. They stay mostly as monatomic elements. However, I can take, let's say, sulfur and oxygen, and I can make sulfur dioxide. This is a molecular compound. Why is it a molecular compound? Simply because it's made up only of nonmetals. I could do the same thing with carbon, which is a nonmetal, and oxygen. This is carbon monoxide. I could have something that looks like this. And remember that hydrogen is a nonmetal. It's not a metal. So I could take, let's say, nitrogen, and I could put it together with 3 hydrogen. This is actually called ammonia. And this is something you scrub your floors with. And so molecular compounds are made up only of nonmetals. And there are just a host of molecular compounds that you're familiar with, and we can name them. And I'm going to show you how to name all of these types of compounds. So let's take a look at H2O. Hydrogen is a nonmetal. Oxygen is a nonmetal. They form H2O, which you're very familiar with, hopefully. You've got a lot of it in you, and hopefully you take a shower once in a while. And this is called a molecular compound. This is sodium chloride, and sodium chloride is made up of sodium and chlorine. Sodium's a metal, chlorine is a nonmetal, and so this is going to be an ionic compound. This is hydrogen, a nonmetal, chlorine, a nonmetal, so this would be a molecular compound. I think you're getting it. This is a compound made of carbon, a nonmetal, hydrogen, a nonmetal, oxygen, a nonmetal, so this would be a molecular compound. This is iron, which is combined with a nonmetal, chlorine. You know that iron's a metal and a nonmetal form an ionic compound. We actually call this iron 3 chloride. And there we are. Types of chemical formulas. All right, we have molecular formulas, which give us a fair amount of information about a compound. I'm going to show you how to describe it. Empirical formulas. Empirical formulas are the simplest formula that you can have for a compound, but they're the easiest to determine when you're in the lab and you're trying to figure out what something is. Empirical formulas are easy to determine and they give you the least amount of information, but it's valuable. And then you have structural formulas. This is the formula that's going to give you the most information, and it's the hardest to determine. It takes the most work and the most instrumentation to figure out what the structural formula for a substance is. All right, so number one in information, structural formula, and the hardest to determine. Number two in information, a molecular formula, not too hard to get out of an experiment. Number two in information, but it does give you more information than the empirical formula. It's the number three in information. And you need to know all three, particularly the top two, molecular and empirical formulas. So molecular formulas, they provide the elements present in the compound and the actual number of atoms of each element in a compound. So for instance, here is glucose. Now this is a molecular formula. It gives you the number of carbons in this compound, the number of hydrogens in this compound, and the number of oxygens in this compound. So 6 carbons, 12 hydrogens, and 6 oxygen atoms. Exactly. Molecular formulas give you the formulas for molecules, all right? So molecules are simply the smallest unit of any substance that's composed of more than one atom, and there are 6 carbon atoms, 12 hydrogen atoms, 6 oxygen atoms. So this is a representation of of a molecule of a compound. It's a compound because the elements are different in it. And it is a discrete entity, a molecule. It's a discrete, self-contained entity, and I'll show you what I mean by that. Empirical formulas, we can go ahead and do the empirical formula for glucose. Let me show you how we got the empirical formula for glucose. An empirical formula is just the simplest whole number ratio of elements in a compound. So if I take all of these subscripts and I divide by the whole number 6, that's going to give me CH2O, which is an empirical formula. Now that's a lot less information, but it's easier to obtain from an experiment. Empirical formulas, as I said, they don't give you very much information. They just provide the elements that are in the compound and their ratio, their simplest ratio. So this is C1H2O1. This still is the empirical formula for glucose. We got it by dividing 6 by 6, 12 by 6, and oxygen by 6 from the previous formula. That's how we got the empirical formula. So it just gives you this information. It's a 1 to 2 to 1 ratio, carbon to hydrogen to oxygen. So that is not a lot of information, but sometimes it's enough to derive the molecular formula based on your experiment. All right, structural formulas are going to give you the most information. They not only give you the number and type of atom that's in the compound, it gives you the way that they're attached to each other. So this is the structural formula for glucose. We've still got 1, 2, 3, 4, 5, 6 atoms of carbon. You've got 12 atoms of hydrogen and 6 atoms of oxygen. But now it's showing you how they're connected to each other. And this is going a step further. It's even giving you the conformation of the structure. And you can see that this conformation looks a little like a chair, like a lounge chair that you might have at the beach. And so we call that the chair conformation. Now, that is not something you need to know in this course, but you will learn it if you take organic chemistry and you start looking at organic compounds and ring structures and the way they arrange themselves to be in their most relaxed state, because that's what all of these, it really is all about energy, and these larger molecules will arrange themselves to minimize what we call steric hindrance. And that's just a way to say that it gets into a relaxed state, okay, a relaxed shape. So which of the following formulas is empirical? Well, this is really easy to determine. If I can come up with a simpler ratio, and you already know about this one. I'm going to divide by 6 here, divide by 6. This is going to be CH2O. That means that neither of these are empirical. I could divide both of these subscripts by 2. That's going to give me CH3. All of these subscripts I can divide by 2. That's going to give me CH3O. But this is understood to be a 1. Well, there's no simpler number than 1, so there's no divisor that I can divide these by that will simplify this formula. So that is my empirical formula. And all the rest of these formulas are molecular formulas.